This video is going to explain the techniques that I used for the project, why I use them, and show how they work. Show how some of them work. We'll start with object-oriented programming. I chose to use object-oriented programming because using classes is the most efficient way to create objects. I used objects to create the deck and to create the cards because it was the most efficient way of manipulating the values and creating the cards. Using classes, I can create separate card objects, which is a lot easier, and I can manipulate each object individually. Instead of just combining two attributes together, I can instead create every individual card objects and reference where the card is in the deck object. So this is useful because it's a lot easier to deal with during calculations, and it's a lot easier to deal with especially when displaying the cards on the screen, as every card has its own value which can be used during the calculations, and every picture can simply be blitted on screen, so every object can be displayed on screen. Finally, using objects make the games more realistic, so I'm creating 52 card objects. The same wouldn't be true if I wasn't. So the card class works by defining three attributes of what makes up a card: a value, a suit, and its own unique look. And it will change the values of the 1, 11, 12, and 13 card to their respective face cards. The deck works in a very similar way. The deck is a queue, which will be explained later, and will also contains a build method, which for every value in 1 to 14, because Python is non-inclusive, it will give a value to diamonds, clubs, hearts, and spades. Using inheritance was a bit more useful in getting the program to run as intended. So when I created the deck of cards in the deck class, it was just easier to instead build all 52 cards within the deck and then place them straight into the deck object. The deck is more useful as an object anyways. So if I could create the 52 cards, it just makes it a bit easier to deal with, as well as the fact that with the when I can build a deck of cards, all I need to inherit, or all I need to know, is what a card is. That's what I defined earlier on here in the card class. So if I can define what a card is beforehand, I can then inherit that into the deck and then create those 52 cards within the deck. I use dynamic object creation due to the way that the game gets rid of cards. So at the end of every round, within the player class, I will clear the player's hand. The player is an object, and their hand is an attribute. So whenever the game is run, the player and the dealer will both take a card from the deck, self.deck, from the deck object, and place it into their own hand. So at the end of every round, the hand must be cleared, ready for the next round. And I use the Python method of .clear, which is a built-in Python method. This will essentially discard every single card that is in the deck, in the hand of the player at any one time. By doing this, it means those cards are completely discarded and they can't be reused. They can't be added back to the back of the queue of the deck. As such, it means that I have to create 52 more card objects, because as more rounds is played, the less cards are being able to be played from the deck. This means I have to create more objects while the game is running. That's why I have this checkDeck class. Whenever the program detects that it's running low on objects, it will create more objects. Using functions and procedures made the code far more efficient than doing everything manually. The whole point of creating a function means that I only need to define the code once, or define a specific block of code that's going to be used once, and then redo that every time. For example, the define image function near the beginning of the code works by assigning each value, each card, its specific look, depending on its suit. Instead of doing this every time I create a new deck of cards, rather I just need to take this function and run it once. And that can be done every single time I create a new deck of cards. Procedures are also very helpful as they work in the same way. For the update scores and update counters function procedures, the only thing I need to do is to run these, and it will update the counters or update the scores. This is useful because I need to update the counters and update the scores regularly. So as such, instead of having to do it manually every single time that the player's score change or the dealer's score changes, I just need to run the functions or run the procedure, and that will make the code run as efficiently as possible, as it means it doesn't have to translate each line of code manually every single time. It just needs to run the function. This also takes up less lines in the final code, and as such, less memory. I used a queue for the deck for the reason that it's more organized and more structured than just using an array. This is because when the objects in the deck are dequeued or removed, they're removed from the top of the deck to the bottom. This is not only how a real deck of cards will work, it also means that when the deck is topped up, or when the deck is recreated, when it's about to run out, it means that the cards from the old deck are removed first before the new deck is used, which essentially gets rid of the chance of duplicate cards occurring while the game is running. It's also useful for things such as the show queue method and the isEmpty method, especially later on during the check deck method. I used a dictionary in the AI portion of the game for storing and accessing the values that I need for the calculations to perform. I did this by storing an array for every key in the dictionary and using the hand value as the key. This saves memory, as if I was to do so the same way by using an array, I'd have to use the hand value as a reference to an index and store the 0 and 1 hand values, which is useless because these hand values are possible in blackjack. Instead, I can just use the hand values as the key, and then use the two values stored in the array to do the calculations. Using the hand value as the key is better, as I can pass this as a direct argument. Not only is this going to save more space, but it also reduces the amount of extra working out that I have to do during the code. For the deck, I chose to use a queue, but for the player and dealer's hand, I decided to use an array or a list instead. These are very versatile and very organized data types. I use them quite a few times in my program, mainly because they're easy to manipulate and access the objects that are within them. They're very easy and efficient and organized way of storing objects, or any type of data types for that matter. They're useful because they are mutable data types, which means they can easily be emptied, updated, appended to, or removed anything from. They're easy to access, and they're easy to access things from. This is why I use them a lot in my program, as it adds to the relative versatility and efficiency of the final build. I use tuples in the code as well, as opposed to an array. This is because mostly tuples are immutable data types, which means that they can't be changed. This is useful for storing constants, especially for the pictures. The pictures for every single card doesn't change, so it makes more sense that I would use a tuple, as I only need to access the variables within these tuples, or these constants within the tuple. And it means that they can't be changed, which is always useful during the coding of the program, as it means that they can't be that means that every single look and every single card can't be tampered with. And because all of the cards the look of the card stays the same, they all need to be assigned to their suit and can only be read instead. I use local variables over their global counterparts for a couple of reasons, but the main one is that local variables are far easier to track where they're being changed. Global variables, or changing global variables rather, can have a detrimental effect on the program, and they can be changed within a function or out of a function, hence being global. This is sometimes useful, for example, the mute global variable, but it's sloppy programming, and personally I believe that it would be better if I were to use local variables, as it means that they can't be changed from outside the program, and because they have to be passed as parameters. It also means that if they are changed, they're easier to track. Exception handling was a big part of the final program. Exception handling helps me to catch errors before they even occur. This is really useful for debugging, but also useful later on. As the program develops, it will stop the game from crashing. This is useful as this adds to the overall completeness of the code, as well as making it easier to identify errors during the debugging phase and easier to fix them. I chose to store the values for the AI in a CSV file rather than in a database. The reason I chose to do this is that it uses less code and less memory than by using a database. By using SQL, we would have had to use another Python module so that the SQL could be interpreted and executed. This would not only add more to the program, and would make far more sense to store the AI's values locally so that the program could easily access them. It also helps to add to the tailored experience for the user, as their AI values will match their playstyle. If the AI was connected to a central server where all the results in the game and the world would be taken, then the database would be appropriate, but otherwise it's too small to justify. As such, it makes more sense to just quickly load the game locally, or load the AI values locally from a local CSV file. It also adds to the user customization, as well as taking up less memory. Finally, case statements are imperative to ensuring that some of the values are read differently to others. I used case statements, or if and elif statements in the case of Python, so that certain cards that are match the rules of the game. If the deck was used for a different game, I would use a different set of case statements to do the same thing. Instead, I only need to change the value when it is necessary and reduce the amount of processing and calculations that the program needs to do when calculate scoring, instead of changing the value of every single one for no reason. This is the techniques that I used for my program, and these are the majority of techniques that I used. These are all the techniques that I used for my program.